Hi friends, in this video, let's see question on induction machine. Let's see a 400 volts, 50H, 30 HP, three-phase induction motor is drawing 50 amperes current at 0.8 lagging power factor. 50 amperes current at 0.8 lagging power factor. The stator and rotor copper losses are 1.5 kilowatts and 900 watts respectively. Stator copper losses, rotor copper losses respectively. The friction and windage losses are 1050 watts. 1050 watts is the friction and windage losses. And the core losses are 1200 watts. The air gap power of the motor will be here they are asking air gap power. Air gap power is nothing but rotor input nothing but the total input minus stator losses. Total input minus stator losses minus core losses. This is the answer. That's it. Completed. So, air gap power is equals to we don't know the input minus stator copper losses. Stator losses 1500 watts minus core losses 1200 watts. What is the input here? Here the power input is equals to root 3 VL IL cos pi. So tell me what is the answer? Root 3 VL is the 400, IL is the 50 and cos pi is the 0.8. If you calculate this, you will get 27,712.8 watts. Nothing but 27.712 kilowatts. 27.712 kilowatts. This is the power input. So substitute this power input 27.712 kilowatts. So 27.712 minus 2.7 kilowatts. 2.7 kilowatts. So tell me what is the answer finally? 27.7 minus 2.7. Then the answer is 25.01 kilowatts. 25.01 kilowatts. So option C is a 100% correct answer. Option C is a 100% correct answer. Very simple question. We know that generally air gap power nothing but rotor input nothing but total input minus stator losses minus core losses. Yes or no? Like this. This is the total input. These are the stator losses. This is the air gap power. Air gap power nothing but rotor input. Total input minus stator losses is equals to air gap power. But here core also is there. They given core losses also. So we have to subtract core losses also. Then you can get the answer. The losses are stator losses and core losses. So input minus stator losses and core losses is equals to air gap power. Air gap power is nothing but the rotor input. This is a question very important, like this questions expected for competitive exams. Understood? Very important this question also. Let's see here. A 200 volts 50H single phase induction motor has following connection diagram and winding orientations shown. MM dash is the axis of main winding. MM dash is the axis of main winding. And A dash is the axis of auxiliary winding. A dash is the axis of auxiliary winding. These two winding axes should be 90 degrees. We know this. Next, Directions of the winding axis indicate direction of flux. Directions of the winding axis indicate direction of flux when currents in the windings are in directions shown. Generally, the current directions and flux directions they given in the figure. Parameters of each winding are indicated. Parameters also indicated. When switch S is closed, the motor. When switch S is closed, then the motor rotates. Rotates in clockwise, rotates in anti-clockwise, doesn't rotate, rotates momentarily and comes to halt. This is the question actually. In generally, I said you many formulas for this question. The first formula is tan inverse of xm by rm and tan inverse of xa by ra. One and next one. This is also known as theta m and theta a. And next one xm by rm and xa by ra. And next one lm by rm and la by ra. And next one tau m tau a. If this value is greater than this, then it rotates in counterclockwise, anti-clockwise. If this value is greater than this, anti-clockwise. If this value is greater than this, anti-clockwise. If this value is greater than this, for example, if these are greater, clockwise, but if this is greater than this, anti-clockwise. Like this, we have if all these less than, anti-clockwise, greater than, clockwise. If all these are equal, then no rotation. If these all are equal, if this is equal, then no rotation. Like that we have to conclude. But here, if you use these formulas, the answer may not exact correct answer. You must and should use only this formula. Nothing but theta m is nothing but this one, theta a is nothing but this one. But don't use these formulas because you may get the wrong answer. For example, if you take xm by rm and xa by ra, for example, check it. What is xm or lm? Here we don't have xm, lm by rm and la by ra. What is lm? Lm is the 0.1 by pi and rm is the 0.1. 0.1 gets cancelled. La is the 10 by pi. And Ra is the 1. So here 1 by pi, here 10 by pi. Always 10 by 5 is greater than 1 by 5. 10 by 5 is greater than 1 by 5. Nothing but La by Ra is greater than Lm by Rm. When La by Ra is greater than Lm by Rm, then the answer is the motor rotates in counterclockwise. But this is may not 100% sure. You must follow these equations only. This is not 100% sure. You must follow the first equation only. Find theta m and find theta a and then calculate. Generally here, the torque T is directly proportional to sine theta, where theta is the theta m minus theta a, where theta is the theta m minus theta a. You have to substitute this theta here. Then you can find what is the torque, and then you can say in clockwise or counterclockwise or no rotation. So to solve this question, we have to calculate theta m and theta a. First calculate theta m. Theta m is equals to tan inverse of xm. Xm nothing but 2 pi f lm. Lm is the 0.1 by pi. Tan inverse of theta m by tan inverse of xm by rm. What is rm? Rm is the 0.1. These two gets cancelled. If you calculate this, you can get an answer 89.4 89.427 degrees. 89.427 degrees you will got theta m. Now calculate theta a. Theta a is equals to same tan inverse of xa. xa is nothing but 2 pi f LA. What is LA? 10 by pi. 10 by pi by RA. RA is the 1. So pi gets cancelled. So F is the 50. If you substitute that value, you will get an answer. Theta A is equals to 89.9427. 89 degrees, 9427 minutes. So here, in general, we know if theta A is greater than theta M, if theta A is greater than theta M, the rotor rotates in counterclockwise direction. Generally, now tell me which of the following is correct answer. Yeah, sir, theta M is there, theta A is there. Here, by seeing the two values, theta M is less than theta A, so answer may be option B. Is it correct? No, option B is may not exactly correct answer. That is may not be exactly correct answer. Let's check again. I said you know, the torque is directly proportional to sine theta. Torque is directly proportional to sine theta. What is theta? Theta is equals to theta m minus theta a or theta a minus theta m. In any way, take the theta. Of course, take minus only. Theta m minus theta a. Now tell me what is the answer. What is the answer? 89.427, 89.9427. So the answer is minus 0.9, minus 0, not 0.9, minus 0.5 change, minus 0.5 change, not even minus 0.5. So see here, the theta value is minus 0.5, minus 0.5. Can you tell me what is sine 0.5? Sine 0.5 is mostly 0. Sine 0, 0. So sine 0.5 also mostly 0. Then can you tell me what is the torque produced in the machine? The torque produced in the machine is mostly 0. Hence the answer is doesn't rotate. Be careful. Be careful. Here theta is very near to 0. Sine 0 is the 0. Here there is no torque production. There is no torque production. If there is no torque produced and it doesn't rotate the motor, this is very simple question actually. Don't make a mistake. Don't make a mistake. Come up to this. Find the theta and substitute the theta and then give me the answer. If it is negative answer, counterclockwise. If the torque is positive, clockwise. If the torque is 0, no rotation. Understood? Understood? Okay. So listen carefully once again. Listen carefully once again. In generally, we have to find out theta m and theta a. Actually, here we can conclude if theta a is greater counterclockwise, if theta m is greater clockwise, if both are equal, no rotation. But don't conclude here in your GATE exam. Don't conclude here because you have a calculator, virtual calci. Now find the theta. Theta m minus theta a is equals to theta. And we know torque is directly proportional to sine theta. Substitute this theta here. Then we can get the torque. And this torque will give you the direction of rotation. Are you okay? Understood? Let's see. A 3-phase 440 volts 6-pole 50 Hz squirrel cage induction motor running at slip of 5%. The speed of stator magnetic field with respect to rotor magnetic field. Speed of stator magnetic field with respect to rotor magnetic field and Speed of rotor with respect to stator magnetic field. Speed of rotor with respect to stator magnetic fields are, they are asking two questions. One is the, first of all, find the synchronous speed. Synchronous speed is equals to 120 F by P, that is 1000 RPM. Here synchronous speed is 1000 RPM. And here the given slip is 5%. If the slip is 5%, what is NR? NR is equals to NS into 1 minus S. NS into 1 minus S. Then the answer is 950 RPM. The answer is 950 RPM. The answer is 950 RPM. Right. Now what they want? They want the relative motion between rotating magnetic field of the stator, rotating magnetic field of the stator, and with respect to rotating magnetic field of the rotor. Rotating magnetic field of the stator, rotating magnetic field of the rotor, relative motion. They said that stator magnetic field with respect to rotor magnetic field. Stator magnetic field with respect to rotor magnetic field. So tell me what is the answer? The stator magnetic field rotates at ns and rotor magnetic field rotates with ns. So the answer is 0 RPM is the speed. So which of the following is correct answer? The first two may be right answers. These two 100% wrong answers. One is completed. Next question. Speed of rotor with respect to stator magnetic field. What they asked? The speed of rotor with respect to stator magnetic field and the rotor speed. Stator magnetic field and the rotor. What is the rotating magnetic field of the stator speed? Ns minus Nr. What is Ns? Ns is the 1000 and Nr. What is Nr? Nr is the 950 RPM. 950 RPM. 5%. 5% reduces. 5% nothing but 50 reduces. So what is the answer? 1000 minus 950 is the 50 RPM. The answer is 50 RPM, the second answer. Where is the 50 RPM? There is no option. Actually, they given wrong options. So the answer is one is the 50 RPM and other one is the 0 RPM. This is 100% correct answer. They given wrong options. Actually, here should be 50 RPM. Here should be 50 RPM. Then it is correct answer. Then it was correct answer. But they won't given like that. They are not given like that. So the answer is the relative motion between stator magnetic field and rotor magnetic field is 0. And the relative motion between stator magnetic field with the rotor is 50 RPM. This is simply the question on speed equations. Right? Understood? Listen carefully. The black rotor current in a 3-phase star connected 15 kilowatts, 4-pole 230 volts 50 Hz. 4-pole 230 volts 50 Hz. Induction motor at rated condition is 50 amperes. At rated condition is 50 amperes. Neglecting losses and magnetizing current. Losses neglected, magnetizing current neglected. The approximate black rotor line current drawn when the motor is connected to 236 volts 57 Hz supply is 236 volts 57 Hz supply is 236 volts 57 Hz supply is. This is the question. Let's see. The black rotor current in a 3-phase star connected machine and 4-pole 230 volts 50 Hz given. Induction motor rated condition is 50 amperes. So what they want here? They want the current at given values. First of all, I am going to draw the black rotor circuit. Losses neglected, right? When losses neglected, there is no current. So this is the, when losses neglected, there is no resistance. When losses neglected, there is no resistance, because if resistance is there, losses will exist. So this is the equivalent reactance. Of course, this is the voltage we are applied. Of course, this is the current flowing in the circuit ISC, black rotor current ISC. Do you know what is ISC now? ISC is equals to simply V by Z. Z nothing but X, because resistance is neglected. ISC is equal to V by Z. So here the ISC is directly proportional to V by F. ISC is directly proportional to V by F. X nothing but F. X nothing but F. So now ISC 2 by ISC 1 is equals to V2 by V1 and F1 by F2, because this is in reverse manner. We want ISC 2, we don't know ISC 2, but ISC 1 they given, ISC 1 is 50 amperes, that is equals to V2. V2 is 236 and V1 is 230. V1 is 230 and F1 is 50 and F2 is 57. This is the answer. So we have to calculate ISC2, the short circuit current at given condition. If you solve this, then you can get an answer. Once check it, sir. 0, 0 gets cancelled. 0, 0 gets cancelled. So ISC is equals to 50 into 236 into 5 upon 23 into 57. 23 into 57. This is the answer. So just calculate this and you can get the answer directly. Calculate this and you can get the answer. Then choose the correct answer. Can you do fast? Calculate it, solve it, simplify it, and tell me the answer fast. Come on, tell me the answer fast. Right? Yes, calculate and give me the answer yourself. You have to calculate. Just use the calci. Don't see simply here. Okay? Will you do or not? Right? A 4-pole induction motor supplied by a slightly unbalanced 3-phase 50H source is rotating at 1440 RPM. The electrical frequency in hertz of the inducted negative sequence current. The frequency of negative sequence current in the rotor is simply the negative sequence current frequency of rotor. Negative sequence. We have to find out negative sequence rotor currents. So see here, the given number of poles are 4 and the rotor speed given 1440 and they given 50 Hz. What is the synchronous speed? For 4-pole 50 Hz, the synchronous speed is 1500 RPM and here the rotor speed is 1440 RPM. Then slip is Ns minus Nr by Ns. So what is the answer? 6 ones are 6 twos are 12 and 5. So S is equals to 1 by 25. 1 by 25 or 4%. We know that 4%, 4 by 100. Nothing but 4% of slip. Right? Now, slip is 4%. But they want the frequency of rotor currents in negative sequence. What is the formula? Rotor frequency is equals to S into Fs for positive sequence. This is not correct. What is for negative sequence? Fr is equals to 2 minus S into Fs is the negative sequence frequency. So tell me 2 minus S. What is the S? 4%. Nothing but 4 by 100 of what is the frequency actually? 50 Hz. So tell me 200 minus 4. 200 minus 4, 196 by 100 into 50. 50 ones are 52s are 196 by 2, nothing but 2 9s are 2 8s are. So the answer is the rotor frequency for negative sequence. Rotor frequency for negative sequence is 98 hertz. 98 hertz. This is your answer. 98 hertz is our answer. Are you okay? Understood? Very simple, sir. Nothing is there. Just you have to remember this formula. That's it. We derived in the concepts. Right? Let's see. A 3-phase 50 Hz 6-pole induction motor has rotor resistance of 0.1 ohm and reactance of 0.92 ohms. Neglecting the voltage drop in stator and assume that the rotor resistance is constant. We know that rotor resistance is constant. And next, given that the full load slip is 3%, full load slip is 3%, full load slip is 3%, the ratio of maximum torque to the full load torque is, the ratio of maximum torque to the full load torque is, we know that formula, full load torque to the maximum torque is equals to 2 into S into SMT upon S square plus SMT square. This is the full load torque to the maximum torque ratio. But I want maximum torque to the full load torque ratio. So maximum torque to the full load torque ratio is equals to S square plus SMT square. What is S square? S square 3% square. 3% square plus SMT square. SMT is equals to R2 by X2. R2 is 0.1, X2 is 0.92, 0.1, 0.92 is 0.1086. 0.1086 R2 by X2, that's why. So, what is that? SMT square? 1086 square upon 2 into 3% into 0.1086. This is the answer. Solve them, calculate them, and give me the answer. So maximum torque to the full load torque ratio. Calculate and tell me the answer first. Calculate it first. Hold the video and calculate the answer. Right? If you calculate this, you can get an answer 1.948. 1.948. Option C is the correct answer. Option C is the correct answer. Here you should remember that SMT is equals to R2 by X2. From this we can get the SMT and we can get the ratio. But don't confuse. We know the ratio of full load torque to the maximum torque. But they will ask you maximum torque to the full load torque ratio in reverse. Be careful. Be careful. Right? A 220 volts 3-phase 4-pole 50 Hz. 220 volts 3-phase 4-pole 50 Hz induction motor of wound rotor type, nothing but slip ring type. Slip ring type is supplied at rated voltage and frequency. Rated voltage and frequency. The stator resistance and magnetizing reactance and core losses are neglected. Stator resistance neglected, magnetizing reactance neglected, and core losses are neglected, negligible. The maximum torque produced by the rotor is, 225% of full load torque. 225% of full load torque. And it occurs at 15% slip. That maximum torque occurs at 15% slip. The actual rotor resistance is 0.03 ohms per phase. The value of external resistance, which must be inserted in rotor, per phase if the maximum torque is to occur at starting. What they asked? They asked how much extra resistance we have to add in the rotor to get maximum torque at starting condition. Listen carefully. Here a 4-pole 50H induction motor. They given that the maximum torque is equals to 225% of full load torque. 225% of full load torque. 225% of full load torque. And this is occurs at slip at maximum torque is 15%, 0.15, 15%. The actually rotor resistance 0.03. Then here R2 is there, SMT is there. Can you tell me what is X2? SMT is equals to R2 by X2. SMT is nothing but 0.15 is equals to R2 0.03 and X2. So X2 is equals to 3 by 100 and this comes here into 15 by 100. 3 by 100 into 15 by 100. So 1 by 5 nothing but 0.2. X2 is equals to 0.2. From the given data, X2 is equals to 0.2. X2 is equals to 0.2. 0.2 ohms per phase. Right. Now, what they said, the value of external resistance which must be inserted in the rotor phase if the maximum torque is to occur at starting. Where we can get the maximum torque? At starting. Starting nothing but the SMT should be equals to S is equals to 1. Because the starting slip is 1. As usually, maximum torque should be occurs at starting. So SMT should be 1. SMT is nothing but R2 by X2. The R2 plus extra resistance by X2. R2 plus extra resistance by X2 is equals to 1. Then we can get the maximum torque at starting. What I done? Just they given the maximum torque and slipped maximum torque and rotor resistance. From this I calculated the rotor reactance. Then after I want external resistance to get the maximum torque at starting. So slipped maximum torque is equals to 1. Nothing but R by X should be equals to 1. What is R? Rotor resistance plus external resistance by rotor reactance is equals to 1. Now tell me, what is rotor resistance? Rotor resistance 0.03 plus external resistance is equals to X2 X2 is equals to 0.2. So the external resistance is equals to 0.2 minus 0.03, that is equals to 0.17. The external resistance is equals to 0.17. This is our answer. Is it okay? Are you okay or not? 0.17. If you add extra resistance of 0.17, then R2 is equals to X2 because 0.03 plus 0.17 is equals to 0.2. Both are equal. When both are equal, then we can get the maximum torque at starting. Are you okay? See here, a 3-phase 50Hz square wave, 6-step square wave, voltage source inverter fed a 3-phase 4-pole induction motor. 3-phase 4-pole induction motor. The voltage source inverter line voltage has dominant fifth harmonic. The line voltage has dominant fifth harmonic component. If the operating slip of the motor with respect to fundamental component voltage is 4%. With respect to fundamental component voltage is 4%. The slip of the motor with respect to fifth harmonic component voltage is, here generally they given number of poles are 4. So NS is equals to 1500 RPM because 4-pole machine, and frequency they given 50 Hz. For this NR is equals to NS into 1 minus S, NS into 1 minus S, then you can get 1440 RPM NR. NR is equals to 1440 RPM. Here, the slip for fifth harmonic component is equals to, fifth harmonics is the negative sequence harmonics. These are the negative sequence harmonics. Hence, the slip is equals to minus 5 times of Ns, because frequency multiplied by 5. Fifth harmonic component. That's why minus 5 Ns minus Nr by minus 5 Ns. This is the slip value. So substitute here, minus 5 into 1500 minus 1440 upon minus 5 into 1500 minus 5 into 1500. This is our answer. This is our answer. If you calculate this answer, here minus 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 gets cancelled out. So 5 into 1500, 5 into 1500 nothing but 15 5s are 50 plus 25, 75 plus 1440 upon 75. If you calculate this, then slip at fifth harmonics is equals to 1.192. You can get 1.192. The slip is 1.192 for fifth harmonic component voltage. This is very simple. You should remember this formula. This minus is due to negative sequence. That's simple. Right? Minus 5 into Ns, minus 5 into Ns. This is due to negative sequence. And the slip for our answer is 1.192. This is very simple but different problem. Be careful. See, a 375 watts, 230 volts, 50 Hz, capacitor start single phase induction motor has the following constants for the main and auxiliary windings. The main winding impedance they given, auxiliary winding impedance also they given, neglecting the magnetizing branch, the value of the capacitance in microfarads, to be added in series with auxiliary winding, to obtain the maximum torque at starting, maximum torque. So I said you already, like this problem, generally the torque is directly proportional to sine theta. If theta is equals to 90 degrees, then we can get the maximum torque. Here, for example, V is here and capacitance going to add in auxiliary winding. When capacitance is added, this is the main winding and this is the auxiliary winding, correct? And here this is called theta M, this is called theta A, and this is called theta, where theta is this one. So we have to find theta M and theta A. And add them. And equals to 90 degrees. Then we can get the maximum. So for that, I already given you a shortcut to get the maximum torque. To get maximum torque, XC should be added. The capacitance added, right? That is in terms of ohms first of all. XC is equals to XA plus RA RM by XM. This is the capacitive reactance we have to add to get the maximum torque. So tell me here, XC, how much capacitive reactance we have to add to get the maximum torque? XA, nothing but auxiliary winding reactance plus RA, auxiliary winding resistance, and RM, main winding resistance, and Xm, main winding reactance. If you solve this, you can get XC is equals to 21.29 ohms. You can get 21.29 ohms. This is the capacitive reactance we have to add to get the maximum torque. But they asked that the capacitance in microfarads. So if you want the capacitance, XC is equals to 1 by omega C. So C is equals to 1 by 2 pi f XC. XC is 21.29. If you solve this, you can get an answer 149.5 microfarads. You can get the answer 149.5 microfarads. This is our final answer. Microfarads. 149.5 microfarads is our answer. So like this problem is very important. This formula, based on this formula, we can get the direct answer. No need to do all theta m, theta a and equals to 90 degrees. No need to do all. So just we have a formula, XC is equal to XA plus RE Rm by Xm. From that I calculated XC, from that I calculated C to get the maximum torque. Very simple question if you know this formula. Right? Understood? Let's see. A star connected 12.5 kilowatts, 208 volts, 3-phase 60 Hz squirrel cage induction motor has following equivalent circuit parameters per phase referred to stator. R1, R2, X1, X2, neglecting shunt branch in the equivalent circuit. The starting current for this motor when connected to 80 volts 20 Hz 3-phase AC source. When connected to 80 volts 20 Hz 3-phase AC. So actually they given the parameters like this. This is the circuit. Here 208 volts is connected. Here R1 they given with refer to primary already. R2 they given, X1 they given, and X2 they given. Actually this is the circuit. Here some current is flowing here. This is at how much frequency? 60 Hz frequency. But now what happened? The circuit is connected to 80 volts line, nothing but 80 by root 3 volts phase, and the frequency is just 20 Hz, not 60 Hz, 20 Hz. Now find the current flowing in this circuit. They want the current. Whatever the frequency, 20 Hz or 60 Hz, there is no change in resistance. But the reactance changes, right? Because reactance directly proportional to frequency, right? Yes or no? So X2 by R before X and after X. X60 by X20 is directly proportional to frequency of 60 by frequency of 20. We know the X60. We know frequency is the 60, frequency is the 20. What is the reactance for 20 Hz? We have to calculate this. So calculate here the reactance for 20 Hz. Let's see. Reactance for 20 Hz by reactance for 60 Hz is equals to 20 Hz by 60 Hz. So reactance for 20 Hz is equals to reactance for 60 Hz. What is the reactance for 60 Hz? 0.41 multiplied with 20 by 60, 21s, 23s are. So reactance for 20 Hz is equals to 0.136 is the answer. So what is the reactance here? 0.136. And of course here also same 0.136, 0.136. Now have to find out the current. Current I is equals to V by Z. What is V? V is the 80 by root 3. V by Z. Z is equals to R1 plus X1. This is the resistance and this is the reactance. R square plus X square. What is the R square? 0.6 whole square plus what is the X square? What is the X square? 0.136 plus 0.136. Write the same. 0.136 plus 0.136 whole square. This is the current value. If you solve this, how much you got? Solve it and tell me the answer fast. Hold the video and simplify this and give me the answer. Fast, fast, fast. Come on. Very good. Very good. So the current I is equals to 70.19 amperes. You will get the answer of 70.19 amperes. This is the current for 20 Hz 80 volts AC source when connected to 80 volts 20 Hz source. The current in this circuit is 70.19 amperes is correct answer. Understood? This is also very important. Yes or no? Right? Understood? Thank you, sir.